explain the error in the following work. So here is an expression, this x plus 1 over x, and what someone has done is they've done some simplification steps and some little basic arithmetic type steps, um, and arrived at a final answer of this x plus 1 over x is equal to 2. Okay, and that's not right. You can tell that's not right by plugging in a couple different x values. If you plugged in x equals, say, 3, you'd have a 3 plus 1, 4, divided by 3, 4/3. Right? That's not 2. So you know something must be amiss. We'd like to figure out what that something is. Um, Let me look at this going from right to left really quick. This equal sign is correct, right? 2 divided by 1 is in fact 2, right? So that is correct. There's no error there. 1 plus 1 is equal to 2. 1 is equal to 1. So this fraction, 1 plus 1 divided by 1, is the same as 2 over 1. So that equal sign is correct. Okay. Um, Here, and this, there's really only one equal sign left, even though it looks like 2. This equation is just this one written down with some crossed out things. Here then must be where the problem is, right? Going from x plus 1 over x to 1 plus 1 over x. How did they get there? Well, what they did was they canceled. And you know that if you have something in the numerator and something in the denominator, and you want to cancel the common factor, the a's in this case, we get to replace the a's with a 1. And so we'll have 1 times b and 1 times c. And of course, we don't usually write that 1 because 1 times b is just b. So we'll usually just write b in the numerator and c in the denominator. But you know from when we're doing factoring type problems that if I have something like a plus a times b, and I want to factor this a out, right, and a is the only thing listed there, I have to put a 1 in its place. So they've done the canceling and they've taken out the a, they've canceled that a, and they've replaced it with the 1. And so that's wrong. And the reason it's wrong is because we cannot cancel these x's, right? And the misconception that is shown in this work is that if we have the same thing in the numerator and the same thing in the denominator, we can cancel. After all, that's kind of what we did here. I had this a here and this a here. It's the same thing. We canceled them. The key difference is that this a and this a are factors. A is a factor in the numerator and a is a factor in the denominator. Here, this x that they canceled is not a factor of the numerator. It's a term of the numerator, right? A term was a piece of an addition or a subtraction versus a factor was a piece of a multiplication product. So this x up here is part of it's a term of x plus 1. It's part of a sum. It's not a factor. So we can't cancel. So the error really is that we can't cancel terms. Can't cancel terms. We can only cancel sums. Or we can only cancel factors. Sorry. We can't cancel terms. We can only cancel factors. So that's the error that this person has demonstrated. And this is a common enough error, and it's a reason why this problem is here. This is a common enough error because this cancellation rule, right, a times b over AC equals BC. A lot of people remember it somewhat verbally and they say, okay, if I have the same thing in the numerator as I do in the denominator, I can just stop writing them, or I can replace them with ones, or I can cancel them. And it's really important that we remember that not only do we have to have the same thing in the numerator and the same thing in the denominator, those things have to be factors. If they're not factors, we can't cancel them.